Hi, this is Q28 question 28, and for this question we're told the curve C has equation y equals x cubed minus 7x minus 6, and they want us to find the equation of the tangent to C at the point where C cuts the x-axis. Okay, so basically C is some cubic curve that looks a bit like this, so we'll call this C, and we don't know exactly where this curve sits, so it could be somewhere over here or like back here, but we know that it's some cubic that looks a bit like this, and we want to find out a tangent to it where it cuts the positive x-axis, so something about like this. Okay, so we're going to want to find out where it cuts the positive x-axis in order to be able to find the tangent there. So we're going to have to find a root of this cube. And you kind of just have to try a few numbers, but you see that minus 1 is actually a root of this, because if you put minus 1 in, minus 1 cubed gives you minus 1, and 7 times minus 1 gives you minus 7, so minus 7 gives you plus 7 minus 6, and so this all cancels and equals 0. So once you have one root, then you can factorize this equation. So basically you say that cubic is going to be x plus 1, so that gives you the root minus 1, times by something. And to get an x cubed term, this x is going to have to multiply an x squared. But then when we multiply out, we're going to have plus x squared, so we want to get rid of that, so we're going to want a minus x squared, minus x, because then this x times this minus x is going to give us minus x squared, and that will cancel with the plus x squared from before. And okay, so now we have minus x when we multiply these two terms together, but we want minus 7x in total, so we're going to have to take off another 6, and then when we multiply these two, we're going to get minus 6x, so minus 7x in total, and this 1 times this minus 6 gives us this minus 6 term. And if you don't trust me, you can multiply this out and see that it's the same as this cubic here. So now, okay, we have one root from this x plus 1, and we're going to have to find the root of this quadratic for the other two roots. And there's many ways to do this, but you can see that it just does factorize. So you want something that multiplies to make minus 6 and adds to make minus 1, and minus 3 and positive 2 will do that. So our cubic actually factorizes to x plus 1, x minus 3, x plus 2, giving us three roots at minus 2, minus 1, and 3. So our curve is actually going to look like, or something a bit like this, not drawn to scale, but we have two negative roots and one positive root at 3. Okay, so we want to find the tangent. So we're looking for a line of the form y equals mx plus c, a straight line. And so we're going to need to know the gradient and also a y-intercept. So the gradient at the point where it cuts the positive x-axis, so gradients when x is equal to 3. So we want a gradient, so we're going to have to differentiate. So if we differentiate our cubic, we're going to have 3x squared minus 7. So if what we're looking for is the gradient when x is equal to 3, we substitute x equals 3 into here. And just substituting that in is going to give us that the gradient here at x equals 3 is 20. Therefore, the gradient of our tangent m is going to be equal to 20. So now we just need to know c, so where it cuts the y-axis, the y-intercept. Okay, so now we found out our gradient, and if you look, there's actually only one solution which has 20 as its gradient, so we can already say that the answer is going to be E. Now, if you had time and you wanted to check your answer, you could work out the equation of this fully, and you work out C as well. So if we were to do that, we know that our tangent line passes through this point 3, 0, so we can substitute that into our equation for the tangent. So that's going to give us our y is going to be 0, and the m is 20, so 20 times 3 is the x, then plus c at the end. So that just means that 0 is 60 plus c, i.e. that c is equal to minus 60. Therefore, our equation for the line is going to be y equal to 20x minus 60, and you can see that that is the same as e.